Alright, welcome to your final chapter of your physics syllabus. We've finally reached the final chapter, magnetism and electromagnetism. We're going to jump straight into magnetism. You will want to have your physics notebook out to be taking notes as usual, as if you were in class, as well as your handout one that I've already given to you. Okay, it should say chapter 9, magnetism and electromagnetism, handout 1. Okay. Alright, if you haven't, just pause, take it all out, and we'll resume the video, alright? Okay, so today we're not covering everything. This is the entire overview of the entire chapter. As you can see, there's a lot to cover, but actually a lot of it is, a lot from here onwards is electromagnets. 18.6 onwards electromagnets, alright? So we're looking at just magnetism, which is 18.1 to 18.5, okay, still a lot. But with this video, we're just going to cover 18.1, okay? Learning roadmap, we only have one thing we want to learn today. That's what are the properties of magnets. It's really fairly simple, fairly straightforward. You should be able to breeze through this quite quickly. Okay, so properties of magnets. Property number 1, magnets attract magnetic materials. Okay, magnets attract magnetic materials. There are a total of 4 properties. Okay, so magnets attract magnetic materials. What are magnetic materials? Maybe some of you might say metals, but that is wrong. Okay, not all metals are magnetic materials. Right? An example of metal that's not magnetic material is like copper. If you put a magnet to copper, nothing will happen, right? So the 4 magnetic materials are iron, nickel, cobalt, and steel. Iron, nickel, cobalt, and steel. You can use this mnemonic to help you, or you can make your own. I need complete silence. Okay, this will help you to remember. I need complete silence. Iron, nickel, cobalt, steel. Okay, if you have an alloy that contains any of these metals, for example, let's say you mix iron with copper, or say nickel with, I don't know, magnesium or whatever, right? That alloy would still be magnetic material, but only because it contains these magnetic materials. Okay, and of course it needs to contain it in a significant amount. So in general, we just consider these 4 to be your magnetic materials. Okay, great. Your next property, magnets have 2 poles. The magnetic effect is strongest at the poles. Okay, so typically you say you have a bar magnet. The ends of the bar magnet is where the magnetic effect is the strongest. I'm sure you know this from primary school, right? If you try to pick up paper clips, the paper clips will all converge at the tip of the bar magnet. Right. In fact, I have a bar magnet here, but never mind. All the paper clips will converge at the tip of the bar magnet. It's strongest there. It won't go anywhere. Okay. So I managed to get my bar magnet. And if I you can see that I have a $1 coin here. This $1 coin is the new Singapore $1 coin, and apparently the new one is magnetic. So if I were to attach it like this, you can see that. Oh, my camera is there. It connects, right? I mean, it attracts and it's quite strong. It can hold up the coin. But if I try to attach it here, nothing is going to happen, right? It's not going to be able to pick it up, okay? Let me show you with the camera here. This is the coin. If I try to pick it up like that, it won't be able to pick it up like that, it comes up. Why? I'm sorry you have to look at such a tiny camera, but why? Because magnetic field, the magnetic effect is strongest at the poles. You'll learn why soon in this chapter. Alright, moving on, a freely suspended magnet comes to rest in a north-south direction, just like this. When you let a magnet hang freely, like this here, on a string or something, it would suspend and it would turn itself, and it will naturally align its north pole with the Earth's north pole. Alright, so you will naturally get this. For this, I would usually do a demo, let you all see it, but I can't do that, so I videoed myself. It's the next best thing. Enjoy the video. Okay, so here I have a bar magnet. I tape the bar magnet down to pieces of styrofoam so that hopefully it will float. Let's see what happens when I put the bar magnet in water, floating on water. Okay, actually I knew that would happen because I already tried it once. And that's a lesson on moments, right? Why did it flip? Because it wasn't stable, right? So you can go revise your moments topic. But anyway, you can see that after a while, automatically it has aligned to a position where north is there, facing there. Oops. facing there, and south is here, right? And no matter how I displace it, let's say I turn it away, because there's no friction, the magnet will just, the floating magnet will just naturally align itself such that the north pole of the magnet will be facing towards north, right? And this happens no matter what you do to it. So this is one of the properties of the magnet that we discussed in class, or that we're going to discuss. And then what happens if you bring another magnet towards it, right? So let's bring the north pole towards the north pole and see what will happen. If I bring the north pole towards the north pole, you see, whoa, immediately it's repelled, right? Again, north pole towards the north pole is repelled. I bring it the other side, north pole towards the north pole is repelled. If I bring a south pole, what will happen? So now south, you can see the south pole, north pole attracts the south, or rather the south attracts the north, right? And if I let go, everything will go back to itself, right? Another property of magnets is, so that obviously shows the property that magnets repel, right? And only magnets can repel magnets. Another cool demo of showing things is the repelling force of magnets. I have these ring magnets here, where I think red is north. So if I were to put the ring magnets, of course now they're just all attracted, right? But what if I put the north to face the north? So I put the red to face the red, you see that it repels, right? And blue to face the blue, red to face the red, so on and so forth, right? So you can see that this is what happens because they're repelling one another, right? It's cooler if you see it in person and you're doing this. It's quite freaky. Yep. Yeah, so I hope you enjoyed that video. The video showed this one, that a freely suspended magnet comes to rest in the north-south direction. You could hang it in a string. You could also let it float, because when you float, you get the same effect. You basically take away friction and let it spin freely. I also showed that like poles repel and unlike poles attract, which is the final property of magnets that you need to know, right? Like poles repel and unlike poles attract. So this is what I demonstrated just now. You put the north pole to the north pole, you see the north pole will start spinning away, and then you bring a south pole, then the north pole will attract each other. Okay, so the north and south pole will attract each other. There'll be a magnetic force applied. Remember forces? Alright. So anyway, identify a magnet. So with these properties that you know how to identify a magnet, if you say, let's scenario 1, you have here metal A and metal B, and then they attract one another. What can you conclude? What can you conclude from this attraction? Actually, all you can conclude is that either A or B is a magnet, right? Either A or B is a magnet. You won't be able to tell which one. Just from this, you won't be able to tell which one, but you know that at least one is a magnet and the other must be magnetic material, because if it was just two magnetic materials or two non-magnets, basically two non-magnets, they wouldn't do anything, right? It's only because they are two, one of it must be a magnet, one of it is a magnetic material, that's why it attracts. So you know one is a magnet, but you don't know which one, right? What if you see repulsion, right? So you see this other scenario here, metal A and B repel each other, right? Then what can you conclude about that? Immediately you can conclude that both metal A and B must be magnets. Why? Because the only test for magnetism is repulsion between two magnets. Okay, I say again, the only test for magnetism is repulsion between two magnets, right? The moment they repelled each other, you knew for sure that both of them must be magnets, because a magnetic material will be attracted to both poles, no matter which side of the magnet you give. This side or this side, the magnetic material is always attracted to it, right? Okay, so yeah, this is kind of like a, I guess, kind of a basic concept, I don't know, which is tested every now and then. Okay, we'll try and hand out later. Okay, so this is a bit of a spoiler. I already gave the example for this, but I mean, I showed the demo in the video, but explain why it seems to be floating. So really it's just because, a simple explanation, just because the faces of the ring magnet that are facing one another are like poles, and because they are like poles, they will repel, and that's why they appear, they are found to be floating one another, because they are repelling one another. There's a force pushing against each other. Alright, So if you have your handouts, would you turn with me to handout 1, question 1? Let's go to handout 1, question 1. Alright, so this is the handout we're talking about. Question 1 looks at learning objective 1, which is state the properties of a magnet. Okay, state the properties of a magnet. In this case, we're looking at specifically the attracting and repelling. Okay, so let's look at scenario 1. I'll just show you how to do this. Basically, we're supposed to identify whether identify all the possible identities of A and B in the following scenarios. So whether it is a magnet or a magnetic material, or whether it's impossible to tell, what are the possible things there. So why don't you go ahead and pause this video, go and try it on your own, and when you're done or you're stuck, you can press play and resume as I go through. Alright? Okay, so in this case, A and B are repelling from one another, so straight away you know that A and B both must be magnets, right? So A must be a magnet. Apologies for my handwriting. A and B must both be magnets because they're repelling each other. Okay, let's look at scenario 2. Okay, scenario 2, A and B are attracting one another. When you flip B around, can you notice that my B is flipped around? Okay, when you flip B around, you see that they repel. So what are the identities here? Straight away you know that as long as you see repulsion, A and B must both be magnets. And down here was attracting because it was like unlike poles, you flip it, became like poles, right? So magnet and magnet. Number 3, you have A and B, they attract, and then you flip it, flip B, they still attract. So what can we tell about this? Either A is a magnet or B is a magnet, while the other must be a magnetic material. Okay, it's not possible for them to both be magnets. If not, after being flipped around, it would have repelled. Okay, so but one must be a magnet because they are attracting one another. So either A is a magnet or B is a magnet, while the other must be a magnetic material. So far so good. Alright, last one. Last one's a bit tricky. I won't blame you if you didn't manage to get an answer for this. A and B sit beside each other and absolutely nothing happens. What can you conclude? Well, there are two possible scenarios. The first possible scenario, if one of them is a magnet, so one is a magnet. If one is a magnet, what's the other one? The other is a non-magnetic material. Okay, this is possible scenario 1. Or, okay, this one is also or, by the way. Or, what's another possible scenario? Neither are magnets. Right? Then whether or not they're magnetic materials or non-magnetic materials, it doesn't make a difference. As long as none of them are magnets, you won't get any attraction or any repulsion. Alright, so this is question 1. With that, we have come to the end of this video. What are the properties of magnets? There are 4 you need to know. Just to summarize, the 4 you need to know are magnets attract magnetic materials. What are magnetic materials? They have 2 poles that affect strongest at the poles. A freely suspended magnet comes to rest in the north-south direction, which I have shown. And finally, last one is like poles repel and unlike poles attract. Okay, so with that, I'll see you in the next video.